A company that actually has flying vehicles in the air. That's a whole different level, of course. So, Fedia, that's exactly where I'd like to start. Could you please tell us about probably the most exciting event, the launch of your first flying vehicle? Tell us a bit more. How did it all happen? What kind of challenges did you face? And in the end, what was the result and why? Why was it launched?
Hello everyone. Why was it launched? Because the guys who were developing the control system finished it a bit faster than we managed to set up the shell production and everything else. And in order to test everything in advance, we decided to quickly build a small device. And yes, it just so happened that we literally made it during the first stage. This is a small copy, let me remind you, of the Nova 2 airship, which is equipped with the same number of engines, and the engine thrust is comparable to its frontal resistance. In other words, it replicates the dynamics of the larger craft. The main steering device is also comparable in power, so this is a small copy of what we plan to build by the end of this year. And we made this small copy, yes, we got it airborne. After all, it's the first device, and honestly, it's a really awesome event. After it took to the air, a lot of people stopped questioning what we do. After all, these are airships that actually fly and are being assembled. The team is in place, designers are designing, technologists are developing technologies, and the production staff are producing. Right now, you can see a video. The assembly process is still being handled by the same people, the designers and technologists. But overall, it's a very valuable experience because in the company, alongside the airship building veterans, there are also young specialists. But actually, they're not that young. Everyone's already an adult. They're just new to aeronautics specifically. And the hands-on experience gained on the ground while assembling this small airship during its near-ground operations and during flights was something the whole team needed. And right now, literally today, he's sending videos. Maybe I'll drop them in the chat. Flight tests are underway, and it's not like in the previous videos where we controlled it with ropes. Now it's already flying freely, and speaking of the new generation, we currently have a school student who's come to us for an internship and is also actively and enthusiastically involved in all of this important work.
He continues the engineering school of airship building.
Of course, it's really cool that the younger generation is getting interested. And one of the missions accomplished by the Nova 01 airship is that it has attracted attention not only from serious specialists and clients, but also from students and school children. Everyone is very eager to take part in the development.
By the way, speaking of attracting attention, I'd like to ask to show the footage with WordStat. We gathered some statistics here, and we were curious to see if, when we started working with airships and when the company AERONOVA appeared, people started mentioning it more often on the internet. And according to the statistics, yes, we can see that they did. Well, with AERONOVA it's pretty clear. There was no company, and then it appeared. But even on the graph where it shows airships, we can clearly see that there's been growth. So, the project has really inspired a huge number of people. Because, as we've said many times, besides the people who just genuinely want to use airships for business or for some personal purpose, there are just a lot of dreamers who simply wish this would finally become available to everyone. And when they see that it's becoming accessible, their reaction matches that.
In aeronautics, there's this historical fate where every project was a people's project. It was supported, and in many countries, one would need to study the history more closely.
So tell me, can we confidently say that the tests are indeed going well? What kind of significant conclusions can we truly draw from this?
Well, look, what does going well mean? It flies, that's clear. No one's going to cancel Archimedes' laws. The control system works. We've established communication with a remote operator. That's all been worked out too. So our airship, via 4G through cell towers with minimal delays, something like 100 milliseconds, I think, transmits all its data, video from 5 cameras, everything you see around it, 360 degrees, and it's controlled remotely. So it turns out that even from the office or out in the field, it works just the same. Right now, at this very moment, they're testing the systems for issuing flight missions automatically. So there are guys out in the field, there's an operator with a remote control. He can take control or hand it back to the airship. They're testing these systems. So, an operator with a remote control and another with a tablet. On the tablet, a flight mission is issued, for example, to hover at a specific point by coordinates at a certain altitude to hold position. Everything is recorded, what the operator does, what happens in the air, whether the task is completed or not. Then the point changes. For example, now we fly over here. Today, tests of this kind are being conducted.
Fedya, you just mentioned that tests are being conducted today, and actually, Ruslan sent me a video, which they're about to play. So, as I understand it, these tests are happening right now, right?
Yes, we're flying there. It's drizzling a light breeze, but we got tired of waiting.
This isn't professional footage. It's the guys on site today recording on their phones to show how things are going.
Anyone in Moscow and the Moscow region knows the weather. Sometimes windy, hail, heavy rain. Elders said the weather wasn't suitable for flying, but we flew.
Fedya, can you briefly tell us more about the control system? As I understand it, this is a really serious development that very few companies have. From what I gather, our system was written from scratch.
Listen, any manufacturer of equipment that has a brain has a control system. Most of the time, the manufacturer develops it themselves because they are the ones who add all the components, the actuators, mechanisms, controllers, and only they truly understand the logic behind how their device should be controlled. For example, when the project is large and the funding is huge, in general, there are few more possibilities. There's an opportunity to create a team of dedicated specialists who will document all the logic and hand it over to someone on outsource, and then someone more professional on the outsource side, so to speak, will handle the whole thing. It takes a bit longer, it's much more expensive, but people do it that way too. Basically, we took the shortcut. We just brought in specialists who know what they're doing and built it ourselves, because no one but us would understand the logic behind controlling our device.
Tell me, when do we plan to say that's it? The specific and comprehensive tests for this device are completely finished, and we've achieved precisely what we wanted.
Listen, our dedicated team operates in a very specific manner. We bring on new people precisely as they are genuinely needed for projects. When a specific need arises, a particular task, we hire a specialist or a contractor for that task, and so on. And now, we really need a highly specialized, experienced test pilot engineer. Basically, we absolutely need a comprehensive and fully equipped flight test complex. Because it's become a bit difficult for us to keep running back and forth between the office and the airfield. We have to time things with the weather, keep things moving with the other aircraft, and so on. To answer your question, testing this little machine isn't going to end anytime soon. We need to fly, keep logging flight hours. We can confidently say yes, it flies, yes, everything works, it needs to keep flying. It needs to fly, the computer needs to fly, system engineers need to clean up the system, maybe upgrade something here and there. Dynamics team needs to refine dynamics, aircraft needs to stay in the air. And for that, we actually need additional, highly skilled specialists who will basically just diligently log flight hours, meticulously break in the aircraft, carefully monitor its time in the hangar, and consistently maintain its overall condition.
So we say we have first flying vehicle, but in reality, strictly speaking, it's not the first, because it's stratospheric, a successful launch before.
Its first airship.
It's the first airship, yes. But let's talk a bit about the stratosphere as well. So, we managed a successful launch. What did we ultimately achieve? And what is the ongoing purpose of this work overall?
Well, yes, the stratosphere is still Archimedes' domain. The lift is created by the same lifting gas. It's just that the vehicles fly a bit higher. It's a very interesting niche from a commercial standpoint for large corporations and governments. Remote sensing of the Earth using stratospheric probes can be done dozens of times more effectively than with satellites. There's the matter of resolution, the number of pixels per square meter. And it's obvious to everyone that with stratospheric probes, the number of pixels will be much higher. And now, satellite technology has hit its limits, so everyone is turning their attention to the stratosphere. There are companies that launch weather balloons, but that's not the same thing. Many militaries launched long-duration stratospheric probes during the Cold War, mainly between the United States and the Soviet Union. Later, those programs were scaled back. Recently, Google alone relaunched this kind of program. They plan to create stratospheric probes to provide connectivity in regions where, for example, there is no internet. That includes Equatorial Africa, Latin America, and so on. Overall, things were going pretty well for them, but for a number of reasons unrelated to the technology, more to do with management and so forth, the program was ultimately shut down. And what's interesting is that our specialists from AERONOVA took an active part in this program. Vadim Zubkovich worked directly on this program on Google alone. And now everyone is coming back to the stratosphere, to the idea that these devices are needed. The only thing required is to invest in the evolution of this device. Just like how they stopped evolving in the 1970s, or how Google made a small step forward, naturally, it's necessary to invest in the evolution of the technology. The technology, in general, needs to become controllable. In other words, it should be a stratospheric airship. What we launched was an uncontrollable probe. We would get caught in a stratospheric current and circle around in the polar vortex, trying to go around the pole. But we didn't make it to the pole because the vortex shifted. This method of flight is suitable, for example, for providing communication, but for monitoring, of course, it's better if the device can learn to hover. To achieve this, it needs to be controlled both in terms of altitude and equipped with propulsion systems. And this is exactly the direction we're actively moving in. We've signed a broad agreement of love and friendship with Bauman University in this area. Basically, about working together. When we first started all this, we were already working with the guys from Bauman University, with Arkady Dukovsky. Back then, though, they didn't have an engineering center inside Bauman University. It was still just a student club based on shared interests. And thanks to our collaboration, it turned out that now this is an engineering center within the institute. We have comprehensive agreements with them. Basically, there's a shared roadmap for the evolution of this technology. There's even a rough idea of where it will be used commercially, specifically the one we have current plans for. We'll be increasing the volumes, increasing the payload capacity, adding controllability, equipping it with various sophisticated features. With different types of ballast tanks, discrete, permanent, or single-use ones, valves, and a whole lot more, basically. The device needs to be further equipped until it can confidently stay in the air for months, so to speak. That's one. And two, it needs to do so within designated areas. Then this will be a breakthrough in our Russian stratospheric history, that's for sure. And on the international stage, it will undoubtedly set a significant precedent, a clear and powerful statement that we are indeed a serious global player, a truly serious scientific and technological company fully capable of taking on such complex challenges and successfully delivering on them. At this point, you truly can't even begin to see how many processes we've developed and how much we've carefully planned ahead. There are absolutely no obstacles left to making it happen. This year, we'll already see significant breakthroughs in this area, And next year, it's quite likely that we'll even see the first trial, small, but still stratospheric airships. Because even a probe, let's say, equipped with engines and able to move against the stratospheric wind, having its own direction, that means it's controllable, and that's what dirigible means, controllable.
That's great. This is something we can already show, and of course, work hasn't just been done on this. This is just a small piece of the iceberg that's visible, but in reality, work is already underway on all the other devices as well. On the Nova 2, the Nova 35, and all the others. Can you talk about that in more detail too? What's being done? When will we be able to see something?
Something big?
Yes, something bigger.
When we set up our shell production, that's precisely what we plan to extensively focus on during the second stage of its development. Yes, one of the major milestones of the first stage is that we've developed the next shell for a small, compact airship. This isn't a Nova 01. Nova 01 is actually a dynamic model of the Nova 2 airship, while this is the commercial version of a small drone. We've developed a shell for it, a shell for the Nova 2 airship, and a shell for the Nova 8 airship as well. And for these shells, we've put together, well, a fully developed shell isn't just a simple shell. It actually has a lot of different essential components, both structural and power elements. Inside the shell itself, there are various internal belts, multiple ballonets, all the necessary actuators, and so on, which are securely attached to the shell, so crucial attachment points and a lot of other truly interesting things. The airship is built on the shell. All these shells were developed, a complete set of equipment was selected for their production, and the technological processes were established right down to the needles. Basically, we've put together the entire list, and now procurement has started for the second stage. The main task now is to equip this production, get it fully up and running, and staff it with employees. In reality, it's not a large number of people, but we have everyone in mind. Most importantly, we have a manager for this production. It's luck we brought him in at the first stage. He got involved and said, "All right, let's do this." The main task, in order for us to see something big flying, is that we really need to set up our own envelope production because no one else will manufacture the airship envelope except us. That's why the equipment will be purchased and set up. The fabrics will be imported, but negotiations are underway to produce domestic fabric specifically for them. The requirements are being clarified and formed. In general, the whole process is being launched. As soon as the envelope production process is fully up and running, we will begin to see a series of relatively small, but still quite significant, unmanned airships being produced. These airships will possess a form factor roughly similar to that of the Nova 01, although you will observe that there are some noticeable differences. And we'll create the envelope for the Nova 2 airship that will be accomplished during this stage.
So, this envelope production that you and Sergey are talking about is probably the most important task for moving forward.
Of course. Even though we've mapped out the company's path toward large, rigid airships with a hard shell, that path goes through creating airships with a soft envelope first. And not having our own envelope production while making airships with a soft envelope is just absurd. Naturally, yes, production is a very important milestone, and during this stage we need to establish it. Then we'll have hands untied when it comes to making envelopes of any shape, size, or volume.
And we also discussed the idea that since we can already produce small batches, we could even supply these devices to our partner countries so that they can operate and demonstrate them as well. But as I understand it, this is necessary for further certification and in general for the development of AERONOVA's international direction. So are we setting this as a goal for ourselves now as well?
Yes, Sergei Semenov came up with this task, this idea, that we need to send each national representative a small device like this one. Because talking about airships is one thing, but seeing them and being present during their flight is something else entirely. And yes, in the context of developing the international business specifically, looking for a client for an airship while actually having an airship as if it's a bit easier. Yes, you will certainly feel much more confident, both you yourself and the potential buyer as well. This will undoubtedly make the entire transaction process smoother.
Yes, I'd like to emphasize here that some people look and say, great, you have airships flying in Russia now, but what does that do for us? And here I want to emphasize that AERONOVA is, of course, currently focused on Russia in one way or another, because that's where the main brains are and the team is here, but the business will be in all countries, it will be international. There's already an understanding of what this could look like. For example, today Sergey talked about creating a holding type structure. All of this will make it possible to operate in different countries, comply with local laws, and also address issues such as certification, like some people ask, will they allow it to fly? Yes, well, in order to get permission to fly, you need to go through a certain procedure and then everything will be allowed. This is just the first step in that direction.
Yes, there's indeed a lot to do. The comprehensive plans are truly huge, and all that's left is to diligently make it happen. That's why, based on our national representative offices, we will be organizing dedicated working groups. Within each country, as Pavel mentioned, these groups will clarify, establish, and work out all these procedures from an organizational standpoint. We'll definitely test all of this on small devices first.
And at the initial stage, we were also purchasing equipment. Was that part of the envelope production?
No, at the initial stage, we purchased metal cutting machines. We bought a lathe milling machine, a milling machine, a 5-axis machine, and an EDM machine. Overall, this is an excellent investment in production assets. Secondly, this gives us much more flexibility in quickly manufacturing small parts, brackets, bushings, and so on. And yes, trying to build airships without a comprehensive machine park means that you will ultimately end up being a customer for those very same airships from someone else.
By the way, Sergey wrote to Miss Semenova says that 51 people are currently working. Mentions that 51 people is already quite a large team, right, Fedya?
Yes, the current team is quite large and substantial, but despite its considerable size, we have not even remotely approached 1/6 of the immense scale of the team that presently exists in Russia, that launched the EU-12 and also the EU-30. For now, we're still strictly sticking to a strategy that is based on absolute necessity, but if we've truly taken on the significant task of creating an entire industry, then it will certainly require thousands of dedicated people working. So right now we're only at the very beginning, much like a small stream. In order to think on an industry-wide scale, we've immediately started the process of forming an association. Is a legal entity that has certain rights and functions in major arenas. For example, when working with states, governments, and so on. An individual legal entity is not considered a player, but an association is. So creating an association for aeronautical technology and its manufacturers is now our sacred mission and duty. So during this stage, we hope to definitely accomplish this. That way we will become even more official, even more serious.
Now, tell us about the land, what Sergey mentioned, and when you and Oleg went to take a look, why does the company need this? What goals are planned to be achieved there?
In order to successfully build the airship, you need to have a suitable place to construct it, and for that the chosen location has to meet certain specific requirements. Then there's a significant fork in the road. Either we purchase a ready-made facility, we rent an existing one, or we meticulously design and build our own. All these options can be combined as there are many tasks, starting with setting up metalworking production. Currently we have it on our premises, but for scaling the space is insufficient. Setting up the shell production also requires space. For example, you can weld the shell in rooms with low ceilings, but to pressurize it to inflate it even just with air, you already need higher ceilings. After all, these are airships. Next, if we've welded and pressurized the shell, we need to deflate it, vacuum it, and then transport it to the assembly site where the airship will be put together. The assembly will take place where it's possible to open gates, roll the airship onto the airfield, and for it to take off. Thus, sufficient specialized facilities are needed, so we decided not to rush headlong into things like let's just buy some land right now or let's immediately build a hangar. There are more optimal solutions available. In general, there are various buildings, diverse structures, and essential facilities located throughout the country. We're actively finding out which specific ones truly suit our particular needs and who is genuinely willing to host us and participate in the important work. Work is underway. And Nova 2 is actually designed in such a way that it can be housed in standard aviation hangars, the kind where Boeings are stored, the ones people fly on for vacations. So yes, for assembling the airship, we can use it, and most likely that's exactly what will happen, because this hangar will be located on the grounds of an airfield. It obviously won't be in the city limits. As for building a truly large, rigid craft, whether we genuinely want to or not, and of course we absolutely do desire to undertake such a significant endeavor, we will indeed be doing it. The comprehensive construction of this massive hangar will soon be well underway, and at this very moment we are diligently selecting the optimal parcel of land where this crucial and extensive construction project will ultimately take place. Well, as we
said at the very beginning, maybe we'll buy or maybe we'll lease. Yes, those were indeed truly the options.
there was some good ideas and options for acquiring ready-made airfields, but neither of them worked out, so it just wasn't meant to be. There's nothing we can do about it, so we moved on. Now, we're also pursuing several approaches, looking for something already built, because something ready-made is enough for us at the first stage, but still we're planning for something much bigger in the future. A lot of work is being done, and there are many partners who say, yes, I have land, let's use mine. With such partners, we've started the process. Basically, we submit information about the proposed construction site to the relevant authorities and find out whether it's possible for us to later allocate some kind of flight zone there, set up an airfield, and so on. Because the relevant authorities, not knowing precisely what's happening right under their very own noses, might later have a specialized team of highly skilled experts come in and say, we want to set up an airfield here. They'll say, it's impossible to do that here. So we're sorting things out and making selections. Of course, we need to hurry because the project was allocated 5 years and 9 months have already passed. Yes, the construction itself will take quite a long time.
It's already been mentioned that one of the main tasks is shell production, but there's also the goal of creating several new devices. So as I understand it, these are small ones, including the current models we've just seen, which need to be upgraded to commercial versions. What else? Maybe we'll see something already flying? Anything airborne in the second phase? In the second phase, we'll only see the small one.
The commercial version of this, you can't really call it Nova 01. It's still essentially a small unmanned airship, a commercial version, maybe even a series. That's quite possible. We'll see. Everything will depend on how quickly production is set up, and that in turn will depend on how fast we can attract funding.
But what about Panova 2? Do we have any clear timelines at this point? Maybe at least for ground tests or something tangible like that?
Well, look, it's all gradually taking shape as we steadily go along. The very first, so to speak, flying laboratory, not a fully finished commercial device, but just the essential shell. From the airship, 2 powerful engines, from the airship, 2 swivel transmissions, ring propeller engines, a comprehensive control system, a robust fuel system, indeed the entire aviation setup. But without the gondola, without the passenger seats, those really nice ones that were drawn UPEV, and without a pilot, it could potentially take to the air this very year. Yes, but again, this is still very much a flying laboratory, not a commercial device, though it will be very close to an unmanned commercial model, but still quite far from a piloted passenger version for human transport and general use. Because the piloted passenger version is still a bit more complicated, it takes a bit longer. You need to choose the right seat upholstery there.
so that it's comfortable?
Well, in general, the stringent requirements for air transport, carrying people on board are truly and exceptionally strict. And just putting together a craft and then successfully flying it, that's precisely what we meticulously do. We carefully assemble it and then confidently fly it. There are simply a number of significant and genuine difficulties, indeed real difficulties. For example, it's quite hard to assemble from the current selection of available components something like the complex and intricate power supply system. You know, the engines we chose are the ones that don't really want to come to our country because they're made in other countries that aren't too eager to send them here. The generators, for example, that will be installed on this engine are the same way. In general, everything has to be aviation grade, everything has to be certified, and so on and so forth. But with UAVs, everything is much simpler.
Fedya, is there anything else you'd like to point out? We also talked about the team there. I'm not sure how interesting that is anymore, in the sense that some spaces are being rented. The team is growing, so basically everyone knows about that, but maybe there's something specific you'd like to highlight about what AERONOVA is becoming right now.
Look, AERONOVA is becoming much more deeply engaged in its very own internal processes. Initially, when we first rented the office space, there was still this lingering echo of the widespread remote work trend. In fact, this trend was quite prevalent. Many people thought it might be possible to create a dirigible remotely, and there were definitely such illusions within the team. Fortunately, all those illusions were shattered by reality that is actually inspiring, positive, and motivating. Right now, the office is really full of people who are actively working. New people are joining, designers are coming in, as well as those who actually build and design specific components and mechanisms. Everyone needs workspaces, desks, computers, and so on. Besides that, we also need to purchase machines and equipment. So yes, it's starting to feel a bit cramped. We're expanding a little. Well, we just recently rented a couple more offices on the very same floor to comfortably fit everyone in, but it's certainly not like you just sit here all day long. For the most part, we're more like a migrating flock. Everyone is working, all the spaces are being used, not a single centimeter is left idle. The team is working, the airships are flying, even the small ones, although the small ones are considered toys for the wind. The bigger the craft, the more stable it will be. We're currently working on developing larger airships specifically for this very purpose. To move on to their production in the second stage, it is necessary to establish envelope manufacturing. The metalworking facilities are ready, and some parts are even already being partially produced. After the Nova 2, we have a new airship in the design phase, which we called Nova 8. It's quite possible that the Nova 8 will remain, or maybe it won't. Maybe it will become the Nova 7 or the Nova 9, we'll see. But we've already started working actively on its development because the clients Sergey mentioned are specifically interested in this size. There is a concrete request regarding payload capacity, range, and in general the functions it needs to perform. I already mentioned in a previous webinar that our aeronautics experts had previously given their assessment of which size range would be in demand. And the fact that this matched the requirements of our current active real clients was just encouraging it. Shows that we're dealing with true experts, that we're on trend, and that we understand and are aware of everything. And work has begun on the new Nova 8. I'm just gradually leading up to the fact that the power unit we initially didn't talk about, it was created specifically for the Nova 8-size vehicles. Work on it is also actively underway. It is fully and comprehensively designed. This is a dedicated metal cutting production facility. It's specifically tailored for that purpose as well. In fact, it has already commenced producing various parts, essential components, and so on. And by the end of this year, maybe even in the fall, we'll already see all of this in hardware, how it will be assembled. If we manage to launch the unit this year, it will certainly be a major victory. Everyone in the aviation industry understands that you can't have an airplane, helicopter, or airship without an engine. So what's happening with the engines? There's a bit of a challenge with the engines. And we were quite fortunate that a very large team, which had spent their entire professional careers working on these complex systems, became available and was actively looking for something meaningful to do. In other words, a perfect place to apply their considerable talent. And this team turned out to be a perfect fit for our project. Their developments were suitable and everything came together. Right from the very beginning of the project, the team worked in a well-coordinated manner, and it's also very satisfying to watch how the engine comes together bolt by bolt, part by part, flange by flange. Everything is already in 3D models. All the mathematical models have been worked out. All the gas dynamics have been refined. All the thermal calculations are done. And now the work on dimensional chains is being completed. Tolerances and fits are specified for each part, and they are gradually being handed over to production. This is also a very substantial body of work in its entirety. It's largely invisible but truly enormous in its scope.